Alright, for this part we are going to look into the physical properties of primary amines and also the basic properties of amine, and later on the relative strength of amine as bases. Okay, so for the physical properties of primary amines we are going to focus on the melting point, boiling point, the solubility. Okay, in the case of melting point and boiling point, relatively your primary amines will have a low melting and boiling point. But for boiling point, when you compare the primary amines with an alkane with a similar molecular weight, the boiling point is kind of higher for primary amines compared to an alkane. Okay, why is that so? Because for alkane it only has weak van der Waals forces to hold them together, hold the molecules together. But for amines, okay, we have extra one forces which is known as hydrogen bonds. Okay, and that makes primary amines boiling point slightly higher than the alkane. Okay, and let's go for the solubility in water. Okay, again the hydrogen bond plays a important role in the solubility of amines in water. Okay, but the solubility of amines in the water decreases, okay, as the relative molecular mass becomes larger, which means when the molecule becomes larger and larger, okay, your amines molecule become larger and larger, the solubility of amines decreasing. Okay, and why it can soluble in water? Because it can form hydrogen bond with the water molecule. Okay, and primary amines has order, and it is also highly polar because of the lone pair electron on the nitrogen atom. Okay, and are both basic and nucleophile. Again, nucleophilic because it has a lone pair electron, and it is kind of lacking or searching for nucleophile normally search for the positive region, right? Okay, so that's why it has a lone pair electron on the nitrogen, and it is also known as a nucleophile. Okay, so let's go for the basic properties of amine. So for basic properties of amine, it is actually a weak base. Okay, it is a weak base, and the nitrogen atom again can use its lone pair on or lone pairs of electron, okay, to form a dative bond with a proton, okay, or with proton in the sense of hydrogen ion. Okay, what does dative bond means? So you should recall your inorganic chemistry, okay, especially in the transitional element, right? Okay, so in this case, if you look into this structure, okay, it is a primary amine actually, okay, and this nitrogen here has a lone pair, right? Okay, and hydrogen don't have any electron. Okay, so when you don't have any electron, because it's already a proton here, okay, so don't have any electron, so how does a bond can be formed? Okay, so it can be formed because the two electron, the lone pair here, okay, from a nitrogen atom can contribute in the bond formation. Okay, normally if you want to form a covalent bond, you have to contribute one from one atom and another one, means it's like a sharing, right? Okay, so for dative bonding, you see there's a two electrons here, which is one lone pair, okay, will be used up for the bond formation. Okay, that's why you see here the molecule, now you have a dative bond. Okay, so that is regarding the basic properties of amine. Okay, but now what are the I mean the addition of it? Okay, basic properties in the sense of like uh, what happens when a primary amines dissolve in water, okay, or reacts with the water. Okay, so normally if you see here the primary amines here, when it reacts with the water or dissolve in the water, so it shows weakly alkaline properties. Okay, how? By producing the hydroxide ion. Okay, so what happened is that, of course, the water here okay, of course the water here is being bonded like this, right? Okay, so this, the nitrogen, like I said just now, is a kind of electrophile, right? Nucleophile, right? So it's kind to abstract, okay, abstract the hydrogen. Okay, maybe I'll draw it here, it's much clearer, sorry. Okay, so let's say you have your CH3 and then CH2 and NH2. So I like say just now, you have a lone pair there, right? Okay, and then you have your HOH, okay, the water molecule. So this one kind of abstract the hydrogen, okay, to form the uh, product here. Okay, so CH3, CH2, and H3 and plus. Okay, and left out with your OH minus. Okay, so this is how the OH is being produced, and that shows the alkaline properties, okay, of amine in water. Okay, and of course amine, what you call produce amine is a basic, all right, so it can react with acid to form salt. Okay, if you can see the second step here, so you have your primary amines react with the acid, okay, to form the salt. Okay, so CH3, NH3 plus, and Cl minus. Okay, and of course this salt, the CH3, CH3 NH3 plus Cl minus, okay, can be converted back into the primary amine, okay, by the reaction with the hydroxides. Okay, for example sodium hydroxides or potassium hydroxides. Okay, so it will produce back your CH3 NH2, okay, plus your NaCl plus your uh, H2O water. Okay, so this is kind of like a, a, a chemical equation to show the basic properties of your amine.